Okay. Good morning, everyone. I am Dinesh.btech. The topic of my presentation is a survey on machine learning based on approaches for stock market prediction, and my paper ID is 214. Next, content of my presentation: abstract, introduction, brief literature survey, methodology, experimental result, conclusion, and references. Next. So basically, this paper is nothing but a comprehensive survey on brief techniques that have been used for machine learning based techniques, and we have also present the experimental result obtained from the analyzing baseline techniques. So these are the keywords: stock market prediction, data pre-processing, machine learning error or prediction accuracy. Introduction. So basically, a lot of firms invest in stock market for gaining a profit. Stock market price prediction is very difficult task because stock price is highly random and volatile in nature. Apart from this, stock market depends on several financial, social, economics, and political parameters. Acquire forecasting is even more challenging due to large data sets and random nature of the stock price movement. Next. So basically, stock market forecasting is a category of time series production. Price is a function of t, v. T represents time and f represents function, and v represents related variables such as time, previous stock price, month, public opinion, opinion on market, and other global impacting features. And next. We represent brief literature surveys on the basis of machine learning techniques that have been in previously commonly. And first paper is Singh 2020, used in effective transfer entropy when existing machine learning algorithms such as logistic regression, multi-perceptron, and long short-term memory (LSTM). And basically, research gap of is this in this paper is low data optimization and dimensional reduction. Next is Walktip, and paper is 2020 and used in optimizing opinion mining and sentiment analysis. And research gap of this paper: no data filtering and optimization approaches. Next. And next is IEEE 2019 paper, and used in pipelining approach between conventional neural network and bidirectional long short-term memory neural network. And again, research gap is dimension reductions and no data optimizations are used in this paper. And next is meanwhile 2019 used in higher order information of time series cross entropy based approaches. Some work similar to effective transfer entropy based approaches. Again, optimization is feature selection not applying, which may increase, and result is high computational cost. And next. And next paper is YGO 2018, and used in adaptive support vector regressions along with particle swarm optimization. So this is a hybrid of SVR and PSO. Again, this is not used in optimizing opinion mining and data filtering. SVR is saturated when we use training data which is very large, and so nowadays SVR is outdated. And the next is Ramin DOS 2018, used in combination of discrete wavelet transforms and support vector regression. WDT used as a data filtering. And again, research gap is SVR is saturated is adding more data and not used in opinion mining and sentiment analysis. Next is, and next paper is YVAC in 2018, and used in combination of two LSTM. First LSTM used for used to avoid the overfitting, and next LSTM for predictions. And research gap is again there is no data optimization and sentiment analysis. Next paper is as Selvin, they used in multi techniques for analysis such as ARIMA, GRACH, LSTM, RN, and a big drawback is closing price are used as a feature values. No other parameters are considered such as opening mining, mean evidence, nothing else. And next is M. Villaha 2016 used in large levels were market and back propagation algorithm for the price prediction of Dhaka Stock Exchange. And again research gap is there is no data filtering and optimization. And next paper is GRM 2016 and used multiple fuzzy inference systems which perform better than adaptive neurofuzzy expert systems. And research gap is again is no data pre-processing and optimization. So this is a summary of brief literature surveys preparing to stock market predictions using machine learning techniques. And methodology, and the most commonly techniques used in research papers: support vector regression, ANN with back propagation algorithm, LSTM. We represent the short summary of these techniques. Support vector regression. So support vector regression is a modified version of the support vector machine. SVR is a classifier and SVM is a classifier and SVR is a predictors. And this is a support vector. This is optimal hyperlines, and this maximum margin. Margin is as long as is better. Next, kernelized SVR. Kernel is using the SVR and to analyze non-linear data sets. It is typically a non-linear function, and this is a function of SVR. We calculate kernelized, and k x comma x dash is a e raised to power gamma and mod of x minus x dash ka whole square, gamma equal to 1 upon 2 sigma, and gamma is called the 3 parameters of RVF and sigma is called the feature factors, and k represent the RBF kernels. X and x dash are the sample in an input feature space, and x, mod x and minus x is the Euclidean distance. And next is ANN with back propagation algorithm. This is structure of ANN, and X represents the inputs and Y represents the output, and W represents weight, and activation functions behavior of the neural networks and decision making. And this is mathematical representation of mathematical representation of back propagation algorithm. And next is back propagation algorithm. In this case, propagation errors are feedback into the input layer, which makes accuracy higher. Next is LSTM, long short term memory, and LSTM is used when data is large and complex time series. It is modified version of neural network. LSTM decide how much previous data to remember and how much to forget. Basically, LSTM has 3 gates: first input gates, output gates, and most important forget gate. So input gates gate which collect the data of present inputs, and output gate which combine all the cells stage, and forget gate which is very important gates which decide amount of data to remember and amount of data to forget. This is a unique feature of LSTM. And next is this is structure of the LSTM. This is input and gates and output. And next is ARIMA. So ARIMA stands for auto regressive integrated moving average, and ARIMA is effective time series predictors, and this is a function calculated to ARIMA. And next is experimental result, and we use experimental and experiment results. This is SVR, ANN, and LSTM on ARIMA, and blue lines show actual price and red lines show predicted price, and this is experimental result. Basically, we have used 4 data sets, SVI data sets, TCS, Infosys, and Reliance. In SBI data sets, ARIMA, LS team are the better perform than ARIMA and others, and TCS data sets, ARIMA is perform better than LS team is better perform than ARIMA and others. And next is Infosys data sets, ARIMA perform better performance than LS team and others, and in Reliance data sets, ARIMA perform better than others. So conclusion, in all four data sets, SVR, BP, AN, LSTM, ARIMA attains the highest accuracy for the fourth data sets. So ARIMA is a better perform than others, and these are the references of my project. Thank you very much.